Okay, section 6.2, the trigonometry of right triangles. Our goal is to learn about trigonometric ratios, special triangles, and applications of trigonometry of right triangles. All right, so let's first talk about trigonometric ratios. So this is a right triangle. This leg is your hypotenuse. This leg is your adjacent angle, and this is your opposite. Notice that here you have your angle theta. So this is the adjacent leg. This is the leg that's opposite, and your hypotenuse here. So sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. Tangent of theta is equal to opposite over adjacent. Cosecant of theta is equal to hypotenuse over opposite. Notice that it's 1 over sine theta, so it's just the reciprocal of this. Secant of theta is hypotenuse over adjacent, and cotangent of theta is equal to adjacent over opposite. Okay? A mnemonic device that many people use for this is SOHCAHTOA. So SOH, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and TOA, tangent is opposite over adjacent. Okay? So this will be what you'll use all day today. Okay? So make sure you are familiar with this. So let's look at an example. Example 1. We want to find the exact values of the 6 trigonometric ratios of the angle theta in the triangle below. So here we have a right triangle. Theta is this angle. We have legs 8 and 15. How can we find this side? First of all, this side is our what? Hypotenuse. Very good. How do we find that? Yes, very good. The Pythagorean theorem. We know that a squared plus b squared equals c squared. And that's thinking of this as a, b, and c, like so. And then that means c would be equal to the square root of, for us, 8 squared plus 15 squared. 15 squared is what? 225. Good. 225 plus 64 is what?
289.
Good. And what's the square root of 289? 17. Good. So that's our missing side. So here we have this as 17. So now we go through and we write everything out. Sine of theta. What's sine of theta? Sine, here's theta. What is our opposite? Is 8 our opposite, or is 15 our opposite? 15. Good, because it's opposite this angle. So sine of theta is 15 over 17. That's opposite over hypotenuse. What's cosine of theta? Good. What's tangent of theta? Good. What's cosecant of theta? Good. Secant of theta? Good. And cotangent of theta? Very good. What questions do you have? Yes?
Are you ever going to want us to go past the fractions? Or
What do you mean go past the fractions?
Simplify past the fraction, or just leave it at the fraction?
If it has a radical in the denominator, I would like for you to rationalize, but writing out a decimal is not necessary. Not for this.
Thank you.
You're welcome. What other questions do you have? Okay. Now, you try the following. Find the exact values of the 6 trigonometric ratios of the angle theta in the triangle given here. You have this right triangle. I want you to find the 6 trigonometric ratios. All right, what is our missing side? What's our missing leg? What is it?
We got 3.87.
No decimal. Leave it square root of 15. Square root of 15. So you have, this is b, so you would have b squared plus 7 squared is equal to 8 squared. Or in other words, b squared is equal to 8 squared minus 7 squared. And technically you put all of that in parentheses, right? And then that means b is equal to the square root of 8 squared minus 7 squared, which gives you 60, the square root of 64 minus 49, which is equal to the square root of 15. What's sine of theta? Good. 7 over 8. What is cosine of theta?
Square root of 15 over 8.
Good. What's tangent of theta?
7 over root 15.
Good. And then we rationalize that by multiplying by square root of 15 over square root of 15. And what does that give us?
7 times 15.
Go ahead.
7 times 15 over 15.
Over 15. Good. What's cosecant of theta?
8 over 7.
Good. What's secant of theta?
8 root 15 over 15.
Good. 8 root 15 over 15. And initially you had 8 over square root 15, but then you had to rationalize it. Okay? Again, this is the last time I will make the comment. Make sure you're working on math in here. Cotangent of theta is equal to what?
Root 15 over 7.
Root 15 over 7. You got it. Yes?
Can you explain the rationalizing again?
Absolutely. So an aside for the rationalization part, let's take a closer look at secant of theta. Secant of theta will be 8 over square root of 15, right? But then you'd have to multiply by square root of 15, move this over a little bit, times the square root of 15, multiply by that, and then this would become 8 square root of 15 over square root of 15 squared. But the square root of 15 squared is just 15. So that cancels like that, and then you get 8 square root of 15 over 15.
And you do that every time there's a
Radical?
in the denominator?
Yes.
Okay.
Yes. What other questions do you have? Was that the same question that you had? Okay. I just want you to be able to identify both. Sometimes if it's open-ended, if it's an open-ended question, you'll accept either one, right? But if it's multiple choice, you need to be able to identify both.
Can you keep that up there for a second?
Sure, we're gonna go through example 2. Example 2. Here, we have this right triangle. This is angle alpha. This is angle beta. I want us to find the following. I want us to find A, sine of alpha and cosine of beta, tangent of alpha and cotangent of beta, sine of alpha and cosecant of beta. What does it suffice for us to do first? Find the missing leg. Good. So we know this is our hypotenuse. This is one leg. So how can we find this leg? Good. 4 squared plus b squared is equal to 7 squared. So that means b squared is equal to 7 squared minus 4 squared. Or b is equal to the square root of 7 squared, which is 49, minus 4 squared, which is 16. I don't know why those are so high. We might write it down a little bit lower. So this gives us the square root of what?
33.
Good. So b is the square root of 33. So this side is the square root of 33 there. Now, sine of alpha here. Sine of alpha is opposite over what? Sine of alpha It's opposite over hypotenuse. So we get sine of alpha is what?
4 and 7.
Good. And beta, cosine of beta would be equal to a what?
Adjacent from hypotenuse.
And what's your adjacent?
4.
4 over
7.
7. So notice that they are the same. So cosine of, or alpha, or sine of alpha is the same thing as cosine of beta. Would you like a minute, couple minutes to try the others? Okay, go ahead and do parts B and C. Do parts B and C. Okay, tangent of alpha. What's tangent of alpha?
Root 33 over 4.
Good. No, tangent of alpha is what? You said square root 33?
Yeah, over 4.
So this is alpha. What's the opposite?
4.
4. Good. So it's the opposite over the adjacent. What's your adjacent?
Root 33.
Root 33. Good. So it would be
4 root 33 over 33.
good. 4 root 33 over 33. What's cotangent of beta?
Adjacent over opposite.
Cotangent of beta is adjacent over opposite. So it's the exact same thing, right? Good. So that's the same thing as cotangent of beta. Very good. What is secant of alpha?
Hypotenuse over adjacent.
Secant of alpha is hypotenuse. What's your hypotenuse? Over adjacent?
Root 33.
Root 33. So you would have 7 over root 33, or what?
7 root 33 over 33.
Good. And what can you say about that in relation to cosecant of beta? 33, not 3. 33, not 3.
They're equal to each other.
They're equal to each other. Good. So that's the same thing as cosecant of beta. Excellent. What questions do you have? Okay. So now there are a couple of special triangles you need to know. There are a couple of special triangles you need to know. And they are as follows. You have a triangle that is 90 degrees, and this angle is 45, this is 45. They add up to be what? 90, okay. So here you have the triangle has angles 45 degrees, and 90 degrees, right? Or in radians, pi over 4, and pi over 2. So notice that the legs are 1, and then the hypotenuse is the square root of 2. Your other special triangle is the one that's a 30, 60, 90 triangle, okay? So your legs would be 1, square root of 3, and then 2. So again, this is 30 degrees, 60 degrees, and 90 degrees, or pi over 6, pi over 3, and pi over 2 in radians. Now, note that here you can read off of everything from the first quadrant. You can say what cosine of 45 degrees. It would be 1 over square root of 2. Okay? You can talk about sine. You can identify the cosine and sine and tangent values of the entire first quadrant knowing these two triangles here. Okay, so make sure you go through and know your unit circle, because that's what this is connecting the idea to. Does that make sense?
Yeah.
Okay. All right, so now let's go through an example where we are going to solve the right triangle. We are going to solve the right triangle. And what you want to remember is the information from the previous page. Well, not, yes, hold on. Okay, so remember that you have sine, you have SOHCAHTOA, right? You have that, okay? Do you have questions? All right, so here we want to solve the right triangle. So here you have an angle of 75 degrees. This is 90. What is this angle?
15.
15, good, because you have 90 degrees. So the other angle is 90 degrees minus 75 degrees, which is 15 degrees. So we have this now. And now we need to solve it. So we need to find the other legs, okay? So what we're given, this is 100. How do we go about finding the other legs? Yes?
You use Pythagorean theorem and it would be written as 100 squared plus b squared equals c squared.
But then you have two unknowns.
That's true.
You said use the Pythagorean theorem. You said that would give you 100 squared plus b squared equals c squared, but then you have two unknowns. What can you use here instead of that? Let's think about this. Let's think about what we know here. Sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Here, we don't know certain things, but here, the tangent would be opposite over the adjacent. So tangent this is really a bullet. Tangent of 75 degrees, if we label this side as B, that is C, that would be equal to 100 over B, right? Because it's equal to opposite over adjacent. So that means that B times tangent of 75 degrees is equal to 100, or B is equal to 100 over tangent of 75 degrees. Make sure your calculators are in radians. What is this 2 decimal to the nearest hundredth? So 2 decimal places out. So you get 26.79. You get 26.79 here. So in degrees, you have 100 divided by tangent of 75 degrees is approximately 26.79. You could also get that by saying that that leg has length 100 times tangent of 75 degrees. 100 times tangent of 75 degrees will give you 26.79 as well. Okay? So, we found B. So B is 26.79. And then we need to find C. And to find C, you could use your Pythagorean theorem like you mentioned earlier, now that you know what B is. So the hypotenuse, you will have C is equal to the square root of 26.79 squared plus 100 squared. And that's approximately what? So you get that this is approximately 103.52. So again, note that a couple of things that you could have done to find B, an alternate way, B would be 100 times tangent of 75 degrees. That would give you 26.79. And then the hypotenuse would have length 100 over sine of 75 degrees. And that would be approximately 103.52. And notice that here it's all using this, right? Sine of 75 degrees is equal to opposite over hypotenuse. So that means that your opposite over your sine of 75 degrees would give you this. Here you have it. Okay? All right. What questions do you have? None right now? Okay. Let's look at part B. Let's look at part B. Part B. You have 400 this side. I did not mean to write there. Highlighter. This side, your hypotenuse is 425. This angle is 3 pi over 8. Would you like a few minutes to solve it?
Yeah.
I'll give you a few. Right. What is the missing angle? Very good. The missing angle is pi over 8. Missing angle here is pi over 8. So notice that you have pi over 2 minus 3 pi over 8. That would, you multiply pi over 2 by 4 over 4. That gives you 4 pi over 8. So that's the same thing as 4 pi over 8 minus 3 pi over 8, which is pi over 8. So that's the missing angle. Because remember, this is 90. These two need to add up to be 90. So this, finding this one, you can take 90 minus this. So the pi over 2 minus this, and that'll give you pi over 8. Does that make sense? Yes, no? Okay. So that's your missing angle. And now, to find the others, what did you get for the adjacent leg? Very good, 162.64. So the adjacent leg is, or has length, it has length 100 and, well, I'll write it out. It has length 425 times cosine of 3 pi over 8, which is approximately, as you said, 162.64. Now remember, where in the heck would that come from? Remember, as I said, cosine of theta and aside. Cosine of theta is equal to adjacent over hypotenuse, which means if you solve this for the adjacent, that means that the adjacent is equal to your hypotenuse times cosine of theta. Well, theta is 3 pi over 8. Your hypotenuse is 425. So you get this. Does that make sense? Okay. What is the opposite leg? Very good. It has length 392.65. How can we write that? Pythagorean theorem works. You can use that. That's a for sure way to go ahead and find it algebraically every time. You can also use the mnemonic device. If you do that, remember, your Pythagorean theorem is a for sure way. That's legit, so good job. Here, you can also use the fact that sine of theta is equal to what over what? Opposite over hypotenuse, which means that your opposite is equal to your hypotenuse times sine of theta. So, in other words, here, you would have 425 sine of 3 pi over 8. And again, either way is sufficient. The way that I've learned it was always using the Pythagorean theorem. But this is another way you can do it. Not long. What other questions do you have? Okay? So, an observation here. Note that if you have this right triangle here, these are sides A and B, R is your hypotenuse. If you know the hypotenuse R and an acute angle theta in a right triangle, then the legs A and B are given by the following. A would be given by R sine theta and B would be R cosine theta. This is something that you can use all the time. Okay? If you know the hypotenuse, then your legs A would be given by R sine theta, B would be given by R cosine theta. Okay? So now we need to talk about some terminology, because now what we're going to do is we're going to take what we've learned about right triangles and apply it to real world situations. So we're going to look at some word problems. And you're so excited, curb your enthusiasm just a little bit. Okay? So we need to introduce some terminology. Suppose you have an observer here and you have an object that the observer is looking at. This angle, this is called your line of sight. This, from the horizontal point to the line of sight, that's your angle of elevation. Okay? Now, suppose you have an observer here looking at an object that is below your horizontal. So you have your horizontal here. The object is below the horizontal. This is your line of sight. And notice you have an angle of depression. Okay? So if you have an observer here, you have a horizontal. Then if your object is at the top, suppose this is a building, the object is at the top of the building, the observer looking at this object, this is your line of sight. This, from the horizontal to the line of sight, is your angle of elevation. Here you have an observer, and you have an object that's below the horizontal here. This is your line of sight. This is the angle of depression. So you have angles of elevation, angles of depression. Okay? Now let's look at an example. From the top of a 200-foot lighthouse, the angle of depression to a ship in the ocean is 23 degrees. How far is the ship from the base of the lighthouse? From the top of a 200-foot lighthouse, the angle of depression to a ship in the ocean is 23 degrees. How far is the ship from the base of the lighthouse? How can we go about finding this? Yes?
Set up a triangle.
Set up a triangle. What is it going to look like?
It's gonna, your vertical axis is gonna be 200 feet. And your horizontal is going to be your unknown,
Horizontal is above or below?
below.
Here?
Yes. And then your hypotenuse is your line of sight. The angle of depression from the top is 23 degrees.
So here?
Yes. Where your horizontal and object axis meet is a 90-degree angle. And then you would solve for the other angle.
So you just need to solve for x. You just need to find out what x is. How do you find out x? Mm-hmm.
Just start by finding the missing angle.
Do you have to find a missing angle here? No. What can you do?
Use tangent.
Use tangent. This is where knowing the ratios come in handy, okay? That's why I was trying to apply them in the previous examples. Knowing your ratios is very useful. Tangent is equal to what over what?
Opposite over adjacent.
Good. Opposite over adjacent. So tangent of 23 degrees is what over what? X over 200? Does everybody agree with it?
Yeah.
What do we get?
200 times tan of 23 degrees equals
Does everybody agree with this?
Yes. Yeah.
What did you get?
84.89 feet.
84.89 feet.
Yes.
Does everyone agree?
Yeah. Yep.
I got something different.
What'd you get?
I got 471 feet. So what do we do? Let's go back and read our problem. So it says from the top of a 200-foot lighthouse. So we have a lighthouse, 200 feet. It says the angle of depression to a ship. So because it's an angle of depression, that means that we should be looking like this, right? So our horizontal should be up top. Oh, our horizontal should be up top, right? It makes a difference whether your horizontal is up top or below, right? Because we have to make sure that we're going through and we're reading it and translating. So remember, from the top of a 200-foot lighthouse, you have this. Your lighthouse, 200 feet. It says the angle of depression to a ship in the ocean is 23 degrees. Angle of depression. So you have your horizontal, you have your angle of depression is 23. So now you know your tangent. Your tangent of 23 is your opposite over your adjacent. So tangent of 23 degrees is equal to your opposite over your adjacent, which means you have x times tangent of 23 degrees is equal to 200, or x is equal to 200 over tangent of 23 degrees. And that's approximately what?
471.17.
Good. 471 point what? 17 feet. So this was not the correct way. This is. So make sure you read your problem carefully. I wanted to go through that so we could see, like, make sure you understand your angle of depression versus your angle of elevation. Where your horizontal is. It makes a big difference. What other questions do you have? Okay, let's look at another example. A woman standing on a hill sees a flagpole that she knows is 60 feet tall. What can we go ahead and fill in? Can't hear you?
The flag, 60 feet.
This is 60 feet. Good. That side is 60. Then the angle of depression to the bottom of the pole is 14 degrees. So from here to here, you have 14 degrees. The angle of elevation to the top of the pole is 18 degrees. So that's this. Find her distance, x, from the pole. Find her distance, x, from the pole. Okay? So let h1, let h sub 1 be the height of the flagpole above elevation. So on our diagram, what is that? So let H1 be the height of the flagpole above elevation. What's elevation?
18 degrees.
The elevation is 18 degrees. The angle of elevation is 18 degrees.
Mhm.
So what is H1 on the diagram?
You don't know that.
You can label it. Where would you label it?
When you're in the main part of the,
I can't hear you.
the main part of the flag,
This part? This part.
that part,
Can't hear you?
that part.
This part here. Good. This is H1. That's H1. Good. Let H2 be the height of the flagpole below elevation. So this portion here is H2. Now we know that tangent, that's right, tangent of 18 degrees is equal to your opposite, tangent of 18 would be equal to your opposite over your adjacent. So it would be H1 over X. But that happens if and only if H1 is equal to X times tangent of 18 degrees. That's multiplying both sides by X. Are you with me? Yes or no?
Yep.
Okay. Similarly, you can say tangent of 14 degrees is what? H2 over X. Good. And that happens if and only if what?
Only if H2 equals X tangent 14.
Good. Good. Now, we know the flagpole is 60 feet tall, right? The flagpole is 60 feet. So what does that mean with what we have?
I mean that H1 plus H2 equals 60.
Very good. That means H1 plus H2 is equal to 60. Because we know that the height of that flagpole is 60. Okay? So H1 plus H2 is 60. We know H1 and we know H2. Substitute them in. So you have X tangent of 18 degrees plus X tangent of 14 degrees is equal to 60. They both have X in common. Factor it out. And you're left with the quantity tangent of 18 degrees plus tangent of 14 degrees. And that equals 60. Then divide both sides by that quantity in parentheses. So you get X is equal to 60 divided by tangent of 18 degrees plus tangent of 14 degrees. That's approximately what?
104.48.
So 104.5 or 104.48, since that's what we've been doing, feet. Good. That's your final answer. So that's the trigonometry of right triangles. Make sure you know your ratios, because your ratios is the driving force for all of that information there. Okay? So that's section 6.3.